Hello everybody. This is lesson 12 of the lecture Macroeconomics. I will discuss slides 67 to 94 of chapter 3, the neoclassical model. Up to now we have developed the neoclassical model without taking into account the use of money as a means of payment for wages, interest rates and goods. To this point, our neoclassical model is a mere barter economy. Our implicit assumption was that firms and households trade labor, savings and goods directly, without the use of money. We introduced a goods price and a nominal wage, but up to now their levels are completely undetermined. Therefore, we have to analyze now what happens in this economy if firms and households use money to make their payments. Why is money necessary as a means of payment? In principle, given the assumptions of the neoclassical model, a means of payment is not really necessary. Since only one type of good exists, which can be used for consumption as well as for investment purposes, firms could pay wages and interest to households directly in units of this good. However, if you make the more realistic assumptions that firms do not produce only one single good but a large number of different heterogeneous goods, the assumption that households can be paid with goods is no longer realistic. In this case, households had to go to a market and try to barter the goods with which they are paid with the goods they want to consume. Even though such kind of markets existed in medieval times, when a common money did not exist, the transaction costs in terms of time consumption of such barter markets would be extremely high in a modern economy with millions of different types of goods. Therefore, today everybody prefers to be paid with money. We postulate, therefore, in the following that households prefer to be paid with money and do not accept goods as a means of payment. This implies firms must procure money to pay households for their factor services, wages and interest payments. What is money? Well, money consists of banknotes and coins. Banknotes and coins is what we call cash. The other form of money that is widely used today is cashless money. Cashless money are bank deposits that can be immediately transferred in a transaction. Technical expression for these bank deposits is deposit money, or sometimes we use also the expression giro money or credit card money. E-money is sometimes also used, or virtual money. So this is basically cashless money. Between the amount of cash supplied by the central bank and the amount of deposit money supplied by commercial banks, as we will see, a direct relation exists, the so-called money multiplier relationship. We will analyze this relation in chapter 6, Monetary Theory and Monetary Policy. In the following, we will assume that central bank produces only cash. There are no commercial banks which create deposit money. So we have an economy where only cash is used to make payments, and cash comes from the central bank directly. This simplification allows us to neglect the process of deposit money creation. As Chapter 6 will show, this simplification does not essentially change the working mode of monetary policy. Consequently, we assume that the money supplied to the market, for which we use capital letter M, consists only of central bank money, cash. Central bank money is always cash. Up to now, we have written all nominal variables of the neoclassical model in terms of their real dimension. This is in terms of quantities of goods. In the following, we will do the same with the money supply of the central bank M. We will divide capital letter M by the price level, capital letter P. The resulting variable is M over P, which indicates how many units of goods we can buy with the money provided by the central bank. This greatly simplifies the graphical exposition of the neoclassical model. In the following, numerical examples show how to interpret the resulting variable, which we call real money supply. The numerical example reveals also that there is a certain similarity between real money supply and the real wage, which we have already discussed. Let's use the following numerical example. Nominal money supply by the central bank is equal to 4,000 euro. Just to give you an idea, currently the cash in circulation provided by the European Central Bank equals about 1,200 billion euro. Let's assume that the goods price level equals 10 euro for 1 kilogram good. And good in this example is of course GDP, units of GDP measured in kilogram. Now, if we start with the formula M over P, nominal money supply over the price level, we have the magnitude which we will call in the following real money supply. If you fill in the numbers, 4,000 euro nominal money supply, and for the price level 10 euro per kilogram goods, we can rewrite this fraction in this way. We have 4,000 euro over 10 euro, and this is multiplied with the dimension kilogram goods. Now the euro sign cancels out each other, and as a result we have 4,000 over 10, which is equal to 400 kilogram goods. So this means that the nominal money supplied by the central bank can be used to buy 400 kilogram GDP. This is the way how we will interpret real money supply in the following. It has the dimension kilogram goods or kilogram GDP. So the dimension of real money supply is quantity of goods which can be bought from nominal money supply. And this shows the similarity with the real wage rate, where the dimension was quantity of goods which can be bought for 1 hour work. As we will see in Chapter 6, most central banks typically offer their money as a credit to the capital market. Consequently, the money supply of the central bank increases the credit supply of households by the value of real money supply. Hence, the total supply of credits equals the sum of savings by households and real money supply from the central bank. So the shortcuts for total real supply of credits equals the savings from households depending negatively on the interest rate, as we know already, plus real money supply by the central bank. So if you want to transfer these considerations on the market diagram for the capital market, how do we have to change the credit supply curve if the central bank adds, for example, 4 little quads real money supply to the savings supply of households? If the central bank supplies this money independent of the interest rate level, we simply have to add these 4 little quads horizontally to the savings supply of the households at every interest rate level. If the interest rate level is 0, at the 0 point of the diagram, we have no household savings. Household savings starts only at this interest rate level. So for a 0 interest rate, we have no household savings, but in this case only the 4 little quads provided by the central bank as real money supply. So credit supply then starts here, 1, 2, 3, 4. In this point, until the interest rate reaches this level, there's no savings supply from households, so credit supply equals up to this level simply the real money supply of the central bank. From this interest rate level on, we have to add savings supply of households to the real money supply of the central banks. If the interest rate grows further and households start to supply positive savings to the capital market, total credit supply is simply 4 little quads real money supply larger than the savings supply of households. If you link now these points with each other, we receive the total credit supply curve. If you omit the savings supply curve, the total credit supply curve now looks like this curve. Next step is now to determine the money demand. As noted above, firms need money to pay their production factors, labor and capital. Consequently, their money demand depends on the sum of their wage and interest payments, which means it depends on household income. As we have already seen, the sum of wage and interest payments, household income, equals GDP under the assumptions of the neoclassical model. We use capital letter Y as a shortcut for GDP. Consequently, the real money demand of firms is a positive function of GDP. So we can write this function as real money demand depending on GDP in a positive way. This means that the demand for money is the higher GDP and vice versa. Since the holding of money causes opportunity costs in terms of foregone interest, it would be justified to add the interest rate into this function as a negative argument. We will, however, for simplicity, neglect this potential impact of the interest rate. It does not qualitatively affect the results, but simplifies our analysis. Firms demand money where it is supplied by the central bank as a credit on the capital market. Real money demand of firms increases, therefore, total credit demand of firms needed to buy investment goods, for which we use the shortcut capital letter I depending on the interest rate. So we have to add now our shortcut for real money demand to our shortcut for investment credit demand. And then we receive our expression for the total real credit demand. So it is investment credit demand by firms plus real money demand by firms. Now we have to add real money demand by firms horizontally to the investment credit demand curve, to this curve here. Let's assume that real money demand corresponds also with the length of 4 little quads. So we have to add 4 little quads to the investment credit demand curve over the whole range. Since we've made the simplifying assumption that money demand does not depend on the interest rate, the new total demand curve simply lies 4 little quads parallelly to the right of the investment credit demand curve. If you now add the real money supply curve to the savings supply curve of households, we receive the capital market with money demand and money supply. As this shows, when money demand is just equal to money supply, in our graphical example here, the length of 4 little quads, the resulting interest rate is the same as the interest rate without money demand or money supply. So if we leave aside money demand and money supply curve, the intersection point of credit demand and credit supply lies on the same interest rate level as with money demand and money supply. This interest rate level is therefore called the natural interest rate. As we will see in the following, the natural interest rate is also the neutral interest rate in the sense that at this interest rate neither inflation nor deflation can result under the assumptions of the neoclassical model. As this shows, when money demand is just equal to money supply, in our graphical example here, the length of 4 little quads, the resulting interest rate is the same as the interest rate without money demand or money supply. So if we leave aside money demand and money supply curve, the intersection point of credit demand and credit supply lies on the same interest rate level as with money demand and money supply. This interest rate level is therefore called the natural interest rate. As we will see in the following, the natural interest rate is also the neutral interest rate in the sense that at this interest rate neither inflation nor deflation can result under the assumptions of the neoclassical model. So if a central bank offers the same amount of money that is also demanded, neither inflation nor deflation will result. The price level will then always be stable. If, however, the central bank reduces real money supply below the level of real money demand, like this for example, by the length of two little quads, the total credit supply curve shifts to the left. And the interest rate now lies on a higher level. As we will see later, this will cause deflation of the price level. If the central bank, to the opposite, increases real money supply above the level of real money demand, like this for example, by the length of two little quads to the right, then the new intersection point of demand and supply curves lies on a lower level, such that the interest rate falls. As we will see later, this will cause inflation of the price level. The analysis shows that the central bank can use its monopoly to print money to influence the interest rate on the capital market. If the central bank reduces its money supply, this will increase the interest rate. If the central bank raises its money supply, this will decrease the interest rate. This reaction of the interest rate is, however, the immediate short-run effect, the so-called primary effect. To analyze how much a policy intervention of the central bank affects the economy as a whole in the long run, we have to investigate the consequences of a change in the interest rate for the other markets of the economy too. Now we can put the capital market with money demand and money supply to the market for goods. In this graphical exposition, the assumption is made again that real money supply by the central bank equals real money demand of firms. Both are equal to the length of two little quad, and as a result, as already discussed, the resulting interest rate equals the natural interest rate, which would result without money demand and money supply. Now we have completed the neoclassical model. In the previous diagram, we have derived the demand module. Here, the equilibrium level of the interest rate is determined on the capital market. The interest rate determines then also the level of investment demand and the level of consumption demand, which both add up to the total demand for goods. The production module is given by the next diagram. We know already that the level of real wages and labor input is determined on the labor market. Labor input and the capital stock are then inserted into the production function of firms and yield the supply of goods. Firms offer this supply on the goods market. And we know from Say's law that supply of goods at the resulting capital market equilibrium interest rate equals the demand for goods. So this is the diagram of the production module. We determine on the labor market the equilibrium real wage rate. We use this wage rate then to determine labor input. In the production function, the capital stock comes from the previous period. Together with labor input, we can then determine the level of GDP supply, the production level of the economy. From Say's law, we know that GDP supply is equal to GDP demand at the equilibrium interest rate on the capital market. So this production level, determined here in the production module of the neoclassical model is equal to GDP supply. By Say's law, we know that at this equilibrium interest rate from the capital market, total supply of goods is equal to total demand. Therefore, the supply curve is a vertical line on the goods market, does not depend on the interest rate but only on the production factor input, labor and capital stock. This is now the complete demand module of the neoclassical model with goods supply on the market for goods as determined in the production module of the neoclassical model. So much for this lesson. In the next lesson, we will use the neoclassical model to analyze the consequences of monetary policy on the total economy under the assumptions of the neoclassical model.